This will be a short one. I don't know if that's the right way or not. But if we have a production possibility curve, normally they bow out like that. Now, if we are anywhere on the curve, that's called productive efficiency. If we're anywhere on the curve, we are productively efficient. We have maxed out. We're using all of our possible resources. Productive efficiency. But whether we're here at point D or over here at point B, whether or not we're at the point on this curve that maximizes the satisfaction of the economy, that is called distributive or distributive efficiency. Are we producing what the society needs and wants? Has a different name. Not productive efficiency, but distributive efficiency. Next. Ultimately, the nation that is the most productive will be the wealthiest nation. Is that different than what we said earlier? We're talking about the nation that's the most free is usually the wealthiest nation. Well, freedom gives rise to increased productivity because people can experiment, they can learn, they can get better, and normally, usually, people want more rather than less for the same amount of effort expended. So what is the definition of productivity in terms of equation? It would be output divided by input. So if you were asked, okay, you took that economics course, and I just went to a seminar, and the speaker there was saying that you need to know how productive you are in comparison to your competition out there, because if your competition is more productive than you are, well, then you're not going to be around very long, and so you better start measuring your own productivity and giving a benchmark to see if you're getting more productive or less productive. And so, since you took the course, you get to make the productivity reports for our company. That's your assignment. Right. How do you get a productivity report? Well, you got to know the formula. The formula is output divided by input. Remember, we at earlier lecture, we talked about growing grass for golf courses. And so if we're in that landscaping business and we do lawn mowing, we would say, well, the output would be how many acres are mowed versus how much resources we used. But before we go there, or finish that, you need to know the definition or the equation for efficiency, which is now, do you see the difference? Look closer. Do you see a difference? If A equals B and C equals B, then A equals C, but they're different. They're different. Let's say the output is 10 acres per 5 hours of mowing. What is our productivity? 2 acres per hour. So we could say, well, how are we doing? Are we getting 2 acres per hour? Are we getting 3 acres per hour? Or get less? Now, so what's the difference between these two formulas? Down here, the output would be 10 acres. But with productivity, the input is human labor. In a productivity report, we're trying to figure out how much are we kicking out per amount of human labor. Efficiency, we're trying to say how much output are we kicking out per the input of raw materials or energy. So let's say 10 acres per 5 gallons, that'd be pretty good, 5 gallons of gas. So our efficiency would tell us how efficient our machines are. It would be 2 acres per gallon. That is mechanical efficiency. Now, I said that the wealth of nations is not really dependent upon mechanical efficiency. The wealth of nations is primarily dependent upon our nation's productivity. How much output are we kicking out per human labor hour? That is although the formulas look the same, it's output over input, the difference is what we put in for input. If the input is raw materials and energy, we're talking about efficiency, mechanical efficiency. If the input is human labor, then we're talking about the output is productivity. A short way of remembering it is humans are productive, but machines are efficient. Humans are productive, but machines are efficient. Next, technology and increases in technology tend to move the curve out. Decreases in technology tend to move the curve in. If we had a terrorist attack and it took down the electrical grid, we probably would not continue this class because it would get dark in here. And so you wouldn't be able to take notes. You might be able to hear me, but you're not going to be able to see much. So if we lost our electrical infrastructure, our production possibility curve would go down. That means we're going to be producing less of everything because it's not capable of producing anymore. But technology normally moves this curve out that we're doing more and more with the available resources we have. Now, it might not be uniform. It might be that we're able to produce a whole lot more butters, but the technology doesn't produce any more guns. And this would be a biased technology growth. It's biased in the area of butter. Or we could go the other way. We could have an increase in guns, but no increase in the number of butters. So it could be biased for guns, or it could be biased for butters, or it could be uniform. The technology allows us to produce more of both.